Hello guys, welcome to this tutorial where we are gonna look into how to make a sunhour and radiation analysis in Ladybug, which is a plugin for Grasshopper, which is a plugin in Rhino. Yeah, I know, it's complicated. So let's just begin like this. For the sake of this tutorial, I've tried to make like a really like simple model, just for the calculation time to be very short, because very complex geometry takes a bit more time to be calculated, of course, because there's a lot more info in the model. So I've just made this like simple model here where we have like a plane, actually two planes, and some buildings. Like, let's say this is like the context. So if you load up Grasshopper, of course I have already installed Ladybug, but the way you install Ladybug is you go to food for Rhino, and you just go to the Ladybug tools and you download it. And when you download it, there's gonna be a folder explaining how to install it. It's quite easy. You just drag like a Grasshopper file onto the canvas here, and you're just gonna press some buttons and it's just gonna install automatically. So yeah, that's quite easy. So yeah, you just find Ladybug up here, and this is how it looks like. And for us to make a sunhour or radiation analysis, we will have to like get some weather data. So first you go to the import and you choose the Ladybug EPW map, and that looks like this one. And you're gonna take a Boolean toggle like this, and you're gonna plug it in here and press true, and it's gonna open up a website of like a world map where with different dots on, and these dots represents like weather data we can download. So if we go to like England, let's take Cambridge, you can just copy link to clipboard. I'm gonna do that. Not sure it did though. Copy, and I go back to Rhino. You go to import again and you choose the EPW like this, import EPW. Then we're gonna choose the download weather file here. You're gonna plug the EPW file into this one here, and you're gonna make a panel. And you can make a panel by making this icon here and just press enter, double click on it, and copy the climate file in like this, plug it in the weather URL, just wait for it to load like this. So now we have the weather data, and over here we have like location, we have wind speeds, like we have a lot of different factors that we can calculate our model towards. If we go to the analyze data, we can choose like the analysis period that we're gonna use, and you can choose like the range of which you want to calculate or analyze your model within. We're gonna come back to that later. So that we're gonna use. If you go to the visualize data, we have like we're gonna use the sun path for sun hours. So let's start with the sun hours analysis. So we have the location that you're gonna plug in here. Then you have the center point is actually where you want your sun path to be. So you can see here I have like a sun path here. So if you choose like set point, you can just choose something like in the middle of your where you're going to analyze. I'm just gonna scale it like 0.2 because maybe I'm gonna be able to see it in here. Not even. Yeah, let's choose like this. So we have the sun path here. You can see it says Cambridge, which is the city we chose. Yeah. And then you have the only thing you need now is the hours. And the hours are what we get from the analysis period. So let's say we want to check like in the summer. So you can choose start month, you can actually type, I believe you can type 1 to 12, like that. So then it creates a slider from 1 to 12. Because that's how many months you have in a year. So let's choose 6. Start date, you can choose like 1 to 31, like that. Let's say we wanna check. Let's do the whole month. And just copy this one. End day. Let's just choose 30. Can't remember how many days there is in June. End month. It's gonna be 6 as well. Just copy that one down here. End hour. 1 to 24. So let's just do it from 7 in the morning to 20 in there. Then you check the hoist up to hoist like this. So now we created a sun path, and you can see now there's points on the sun path, and these points is from which the calculation is being made, right? So you can see if I change the hoist now, like if I change the month, you can see I get more points. So if I do like this and I choose like a whole year, I will analyze the thing for 1 year. Yeah, so the points they just visualize from where the calculation is made. And then that's the visualization of the data, right? Then you have to analyze the geometry. So you go to this one here and you choose direct sun hours. And now you have the vectors, plug them in here, and you have the geometry and context. So now you have to define what you want to analyze. So if you make a B-rep, actually even 2 ones, the context, let's start with the context, set multiple. So the context in this case is going to be these buildings and this plane here, like that. And what I want to analyze, the geometry, it's going to be in here, like that. Like that and like that. So the geometry is what I'm analyzing on, how many direct sun hours there are, and the context is what's gonna be like an obstacle for these light rays to enter this geometry that I want to analyze. Then you have the grid size, and the grid size is like if you write 10 in this one, then one of the squares that the calculation makes are gonna be this size. So the smaller the size, the longer the calculation times. So I think I will in this case choose 100 millimeters, and then we can change it later on. So that's gonna be my grid size. Then you have the run component. There you're gonna plug a Boolean toggle in, and when you press this to be true, it's gonna run the analysis. Then you have the legend parameter, and I think if you go here and write legend, you can see you get the Ladybug create legend. Sorry, that's not the one I wanted to use. Legend. I think it's Ladybug legend. Yes, this one, legend parameters. This one you can plug in here. And here you can just like change the values of your analysis. I usually change the colors. So if you choose like a gradient like this and you put it in the colors and you just put a range component in the T value here, then my analysis is gonna be these colors. You can of course choose another preset. I think this is the most known preset people use. You can choose a minimum and maximum value for your legend when it pops up here, but of course that we can change later on as well. And now everything should look like this. All these should be gray, no orange pieces. And when I press run now, it's gonna do my analysis. And that was very quickly. And you can see right now, it looks kinda messy in here. And that's because you wanna hide like you want to hide this, like this. You don't want to preview these, and you want to hide the plane beneath this one, like that. So now it looks cleaner, like that. And you can see these squares, they are way too big right now. So if I just, let's try 10. Let's see, 10. You can see now they are much nicer to look at when I look outside here. And if I change them to 1, yeah, you see when I change it to 1, it's gonna look like this, but the calculation I just did took really long when you think about how small this model actually is, so I cannot recommend that. So just try and find a nice value that represents it quite well. I think 10 in this case fits quite well. And then of course you can change the analysis times here. So let's try 5 here instead. Then it's gonna calculate it for over a month. And you can see how many hours these different colors they represent in the legend. Like that. So that's your direct sunhour analysis. And that's how easy it is to make. If I just go up here and clear these values, and I write show here, I just want to show that the analysis doesn't have to be made like on a plane. You can also choose to have like another geometry you wanna investigate. So let's say that in this case, I clear these values as well. So in this case, my context is gonna be all of these planes and the buildings around, and my geometry is gonna be this one. So right now, it's running the calculation for this building here, and if I just hide it, then you can see like the values are applied on the building now. And right now you might think, why is there not that much sun on the top of the roof? But that's because my legend is like turned around, like these colors here are inverted. So we just remember to make this false when you are changing things, because if I just like change one value, it will calculate and it will do that all the time. So just toggle this to false and do your changes and then run it again. So just there's probably a smarter method for this, but hey, don't judge me. Like that. Run the analysis again, and you can see here we get some values here, like that. So if I just take all of this, just move it up here for now, we can just do the incident radiation as well. So the incident radiation, here you need this sky matrix component to be plugged in. That's the, I can't remember if the cumulative or, let's just try this one. Yeah, so let's take the location here. Then you need the direct and diffuse red, and you find those here: direct, normal red, diffuse, horizontal red, and the hoist as well. And then you plug the sky matrix in here, and then you can just use the same. This was the geometry, this was the context, then we have the grid size, and we need a Boolean toggle, this, and then you can run the incident radiation. So almost the same procedure as the direct sun hours. You just need another component to plug into the incident radiation, and then you can see the incident radiation in kilowatts hour per square meter, and investigate your model like that. So that's actually how easy that is. And like, I believe you can extract the result as meshes like this. If I just hide this one and we bake this one here. Then you can see I have my analysis as a mesh here. I haven't really found out a good way to export this to Illustrator yet with the colors. So what I usually do if I have something like this, I actually take the rendered view because it looks a bit cleaner like that, and I just like take a screenshot of it and just do some small editing if I need it for presentation or something similar to that. So yeah, guys, that's how easy it is to make a sunhour and incident radiation analysis in Ladybug. I really hope you learned something new, and just try and mess around with all of these different components and get to know Ladybug, because it's a great analysis tool and it's free and you can do so many things with it. So this was just the start of 2 of the components I use the most in Ladybug. So thank you for watching. Please like and subscribe, and if you have any questions, let me know in the comments, and peace.